So, okay, so recording now. And now I will screen share. Hopefully the screen share will work this time.
Felix, can you also drop a link to that Hackmd in the chat?
Yeah. Let me do that too. So this screen is being shared. Okay. And what I'm gonna so in the chat for Zulip, you mean? Or the chat for Zoom, I guess. The Zoom chat is probably easiest for the people participating right now.
Yeah.
Okay. So yes, the Zoom chat. Can I get to the Zoom chat from this interface now that I'm sharing my screen? Oh, come on.
It's the button right next to share screen. If you go up to the top,
thank you. Okay, here we go. This is the link to the Hackmd. I'm hoping that you won't need to read along, but the one crucial thing that is in this is the series. So the basis for this session is that I took the source code that you all made, both in the January 20th session and in the January 6th session, and I made separate Pronosco sessions for those because I figured you all had experience looking at those, so you might be interested in seeing stuff with those links. So having said that, let's go ahead and get started with this. So I've got the Hackmd up here and those Pronosco sessions. So what I'm going to do is talk about the basics of Hackmd, and I was going to open the floor to let people suggest which piece of code they want to look at because I went and labeled all of the ones from those sessions with individual letters for people to be able to see like which piece of code they want to care about, A, B, C, D, E, F, G, etc. Which admittedly took a whole bunch of my Pronosco credits away. Pronosco's business model is you have like a set of like 50 depending on what you pay, you can have a certain set of uploads each month, and a lot of my credits were dedicated to this this experiment. So having said all that, I will just choose one, I think, for the purposes of driving the conversation. And I'm going to grab one of the ones that I know. I'm going to skip M because M didn't seem like it actually did the thing that people thought it did. But K, I suspect, might be interesting. We'll see. So I'm going to just scroll down to the K entry here of the demos. But all of these are things that are Pronosco links right here.
Nice.
When you open up Pronosco, the interface now looks like this. I'm going to maximize my screen. And so we have here an interface that has the output that you saw in your terminal when you ran the program on the upper left corner. It's only a suffix of the output, but you can get more of it by hitting these more buttons, and you can get the initial prefix by hitting the more at the top. And so that's the standard out, standard error of the output from your program. And there's a call stack. And if your program ended with an error, then it will have the alerts of things that went wrong when your program ran as another panel down here. So actually, to give a concrete example of that, I'm going to open up a different session, I think, and one is an example that serves that purpose. So this one has 3 panels. We have the alerts here because this thing ended with an error, the call stack here, and the standard out, standard error here. And the most immediate thing we can do with Pronosco is we can say, you know what, I want to know more about something in this output. And you can say, look, I want to know how it emitted this error message and how it figured out to write the word foo here as the identifier that it chose to emit, let's say. So I can click on the F in foo, and a number of things happen. First of all, we get a highlight of the whole bit of output that was emitted here. The call stack has changed so that there's a highlight here, and the source code has changed, so there's a highlight over here. All these things correspond to the point in time when this output was generated. So if I wanted to instead focus on this foo, I could click that, and likewise, these things changed again. It may not seem like much has changed because at this point in the control flow, it's somewhere in the guts of the standard library, but the call stack is changing corresponding to that point in the control flow of the program. So we can scroll up the call stack and see, oh, we're like up here in emit diagnostic, for example. And in fact, you going up, you say, oh, it's a report ambiguity error. And you can say, oh, this is the error being emitted there. So those three things are kept in sync, the output here, the point in the call stack, and the point in the source code. The other thing to note is there's a data flow window down here. And what this does is for the individual character that I clicked on, it shows me how did that character end up copied to that point in the memory at the point where I am at this point in the control flow of the program. And so the really neat thing you can do is you can actually scroll backwards in time according to the copies of that memory, which I'll talk about in a second. Before I get to that, I want to mention something. Pernosco has a habit of opening up new tools in response to certain actions that you take. And I think the default is always put in the lower left corner, which means that as you click on new pieces of memory, you can get a stack of like a whole bunch of data flow views, for example, or other tools might pop up in this lower left corner. So tool maintenance is definitely something to be aware of when one is working with Pernosco. You can create and delete columns by hitting this thing and then drag a box over here so that you can make space for yourself potentially as you're working. That's the first thing I wanted to sort of mention in terms of workflow. So the data flow tool, each line in this, each entry in this output consists of two lines. The even numbered lines are the point in the source code itself, the function name that's invoked. And then the odd number lines is the actual memory action that took place. What location was updated, what's the new value that was plugged in, and what's the old value that was there before. So if you want to know how this thing got the F, that's the very tail of this thing here, where we're doing what's this reallocation call in the guts of somewhere. You have to scroll up the call stack to get some insight into where this actually is in the control flow of the program. You'll see in the document that I wrote, there's a picture I tried to make, which I will put up in the screen that we're sharing right now to talk about it for a second. There's an idea that I want to get across, that there's different different ways of thinking about time in your program, and Pernosco is trying to give you all of these views at once in some way. Like the data flow view is telling you how some value in memory flowed through copies from one location to another, from this value to X, and then from X to this array update, that array update to some pointer update, and then, oops, this is a typo. I was meant to have star P here into some location Z, for example. And that's one way of looking at time, is through that series of events. But each of these events itself has its own context of the call stack, the series of calls that were made to do those copies. And so it's important to keep these things in mind while you're working, because the memory flow, the data flow view, is going to be very low level, focused on individual memory updates. And you have to keep in mind the thing you care about is probably a function call further up on the stack as you're working. So it's important to keep that in mind as you're working in Pernosco, so that when you look at these memory updates, you want to also keep your eye on the call stack over here and look for things that you might be interested in. So you might go backwards here and say, oh, I want to know where that F character came from. You could click that and then scroll up the call stack to see where it came from. And you'll see, there's like an emit to destination thing here. Emitter writer is like copying data all over the place, emit diagnostic. And then eventually your port ambiguity error is maybe something interesting here. So that's an example of how you might go backwards. If you go too far back, like if I were to go all the way to the start of the data flow for F, I'd probably end up somewhere, depending on what I'm doing, I might end up somewhere where it's going to copy the thing that was actually parsed from the source code. Like if you keep going backwards in time for some of these views, you'll end up at some point that corresponds to when the source code was lexically read. And that might be interesting for someone who's working a parser bug, but it's not going to help you with a identifier resolution error, for example. So you can go too far back in time, and that's okay. You can just the interface for Pernosco is browser based, where you can scroll around to sort of undo places that you went that you didn't mean to go to that far back in time for. So let's see here. The other thing I want to mention is that when you do find a place that you're like, oh, this is what I care about. Like I care about this point in the call stack and report ambiguity error. There's a really important tool called the notebook that arguably should be part of the default presentation of Pernosco, because it is so useful, and yet I ignored it for so long because I didn't really know how useful it was. When you find something you care about, you might click on it and you'll see this this sort of faded view over here. You can say, you know what, I care about this, keep it. I'm going to record it for later, as in I want to be able to get back here easily, because as I click around in this interface, looking at other things, you know, for example, clicking back to the memory copies to see where things happened there, and might scroll on this call stack here. At some point, I might say, oh, you know what? I actually lost my place, but the thing I cared about was the report ambiguity error. I can click on that and it takes me back to that point in the control flow. Basically, this is a way to capture things of interest, such as certain focuses in the control flow of your program, where you want to be able to jump back there and see the state of things at that point in time. So this is something you can do where once you sort of want to record something for future reference, you can usually see it come up in the notebook view. So as another example, let's say if I was in this report ambiguity error, let's say I scroll back up and I'm like, I want to know how this error is constructed. This local variable here, error. Well, there's another tool I can use to inspect those things, the local variables tool. And this will show a lot of stuff because there's a lot of context in this thing. But I believe the error itself is I believe it's a top level local variable, or is this inside a closure? Nope, it should be in the top level of this thing. I see error here, but I don't think it's the same one, because I think that's a field of MISC. Where am I? I feel like I'm blind. Well, for some reason, I am not seeing error, and I don't know why. Let me see here. If I go here, if I click this, does that help me at all? No, for some reason, I'm not seeing error in the local variables. I'm not sure why I'm not. Let me go back one step more and see if that helps. Nope, I'm still not seeing it, and I don't know why. I feel like I must be misunderstanding something here. Let's see about right here. If I click back here to this point in the control flow, what shows up now? Still not seeing error. It's possible it got optimized away, although I could have sworn I built this version of the compiler with the optimizations turned off precisely to avoid issues like that. So I'd have to go and investigate further as to why it's not showing up where I expect.
Isn't the last variable?
The last one here, I thought was, I had thought that this presentation was about MISC2. Oh, maybe you're right. Maybe the triangle is what's confusing me here. Maybe the error, you know what? I think that's what it is. This is structured data, and so it puts the triangle here. And I was misinterpreting that as being about you're absolutely right, Esteban. It's something where this presentation, it probably would be clearer if like all of these MISCs were indented, MISC1 and MISC2, because then I would know they're on the same, they serve the same roles. I might tell Kyle about Kyle is one of the developers of Pronosco. I might mention that's an oddity in the interface here. You're absolutely right. That is the local variable for error. Thank you, thank you, thank you. So the point is that if you want to understand something about a local variable, the same way that you can click on outputs in your standard out and standard error, you can also say, I want to understand how error got initialized with this handler value. And you can click on the handler and you get a data flow update for that as well. Doc Jones raised a hand, so I'm going to ask, is it because we're running low on time?
No, not at all. I just wanted to, so in this approach to looking at Pronosco, you're kind of like focusing on an error. And the way that we use it is to like try to figure out what order things are happening in the source code.
Okay.
So could you kind of cover it from maybe that perspective, like using it to inspect the code and see what, because we don't know how the modules that we're working with work, and so we're trying to use this to
sure. Let's talk about that for a second then. So yeah, one thing you can do here, for example, is if you're trying to understand the control flow of a module. So let's go further up my call stack to look at maybe something that has some interesting control flow. I would like to see something with a loop, preferably, but I'm not sure if I'm going to find something quickly. So the thing I was going to mention was, if you're trying to understand the control flow for something, some interesting piece of code that you're looking at, one thing you can do, let's take this for example. So you can say, look, I've got all of these calls that are being made in this routine, like this expansion thing. So one of the first things I mentioned before, how it's important when you find something you're interested in to say, you know what, let's save this in the notebook so I can get back to it easily. That's an important thing to remember to do. And then once you've done that, you can jump back there easily, right? Jump back and forth between report ambiguity error and expansion. And once you've done this, there's a callees view that you can use to say, look, I want to know what all the calls were inside of this function invocation. And this is showing us a lot, right? It's showing us all the subroutine invocations that occurred, which include sub-expressions, but not the calls of those sub-expressions. Like, it doesn't show you the calls that are made inside the things that are invoked. It's just focusing on like what was called and what output did it make, right? You can see for like this, sorry, you can see on each of these lines here, there's something being invoked and there's an equal sign showing what it returned. And so you can do that to get a view of what's invoked, like from in terms of the control flow of your program right here. And in particular, the callees view, if there's a loop, it'll show multiple occurrences of the same piece of the same thing, because what this corresponds to is the timeline of the program executing, where it's showing you just the immediate calls that were made in that space. The other thing you can do is when you choose something of interest, there's these columns here for the lines in the source code, and the highlighted ones are showing you things that were actually executed in this invocation of this function call. So you can click that to say, I want to know what was going on at that point in the control flow. There's a subtle difference. If you click the line number, what it'll do is you've got these pop-up tools over here that tell you about all the times that line was run throughout the entire running of your program. Now, in this case, those are the same sets. Like the outputs for this call and the outputs for all the runs are the same in this scenario. There might be, but there are other ones like there's other cases where you'll see the same thing being run. No, that's not a good example. The other things, you'll see the same line being run many times by different invocations of the function. And so it can be useful to just know about that difference in terms of saying, oh, I want to explore how this thing was invoked at other times. Like I want to know how that line, how this line of code operated in other function invocations. And you can easily get that by this executions of blah overall, like without the in this call suffix that you see over here. That's the first thing I want to point out in terms of like quickly exploring your code. The other thing I want to point out is that when you've actually identified a point of interest and you saved it in the notebook, another thing you can do is you can say, I want to customize the color associated with that point in time. And when you do that, you see everything change in terms of the output of the program and the like points in the call stack. Everywhere there's a notion of time that it's presenting to you, you'll see the colors you chose reflected, which means that you can scroll through things and see quickly, oh, like this line here, that light blue corresponded to this thing. And then if you scroll backwards, we should see that dark blue somewhere here. It might be further up. Yeah, it might be pretty far up. Let me move this panel. Can I move this panel easily somewhere else? For some reason, I can't scroll my whole browser up there enough. I don't know why. Oh, that's because I think it was too far out. Let me add a new column so I can make this whole thing bigger. Hopefully I'll be able to then truly illustrate what I'm talking about. See, all this output from the Rust log ends up like dominating the space here. But like you can see like how the time between this point and this point in the output corresponds to these colored lines here, and versus this line up here was before any of that stuff got emitted. So you can tease out points in the control flow that you want to narrow in on and highlight them, and then say, okay, I want to give them identities in terms of these colors, and it's reflected elsewhere in the interface. So those are examples of things you can do. I don't have advice beyond that in terms of, because I know I've talked with the developers about other kinds of ideas for ways to narrow what you're looking at, but so far the best advice I've seen is to do this kind of highlighting of points and specializing the colors to get that immediate visual feedback about what you care about and when it happened. So yeah, unfortunately, I mean, if you all want to tell me one of the pieces of code you want to look at, like a function name, actually, that's a good point. Does anyone want to take a quick moment to try to recapture when they were looking at this thing back on the 20th of January, like what piece of code they wanted to look at, and then I can pull up that example.
So like if you pull up that Hackmd, there's actually so on the 20th we did something a little weird. We were using the playground to
I know. I saw that.
Yeah, to try to understand the order in which
right. Can someone just tell me that any of these cases? Can someone tell me? Doc, can you just choose one and tell me, like, choose one of the ones that's up here, or one of the ones that's? I didn't get to the ones that were further down that MetaJack was driving, for example. So maybe the problem is that I don't have the playgrounds corresponding to what other people did. Maybe that's my mistake, as I focused too much on what Nico was doing. Like the ones that.
Yeah, that's fine. I mean, you could pick one of the ones that he did.
And but I need you all to do it so you can tell me. You're the ones with the mental context. I need one of you to tell me which one to pick.
Remy, do you have a request?
Not especially. Like the ones we're looking at right now is equally good for me, I guess.
Okay, so give me a function name then to look at.
Just a second. Let's look at record use.
Okay.
Oh, yeah.
Please bring back the. Can you? Yeah. Sorry, I'm waiting for this toolbox to go away.
Sure.
Okay. Record use.
You've got 2 minutes. You've got 2 minutes to hard stop, Felix.
Thank you. All right. So when I type in like record use up here, then it prompts me like, oh, here's all these executions of record use in general, right? So I can say I want to know about all of those executions. That would have been a good example to start with in terms of when I was saying I wanted to see all the invocations of something. Just typing in record use tells me every single invocation of them, and it says for each one what it returned, I believe. If record use does return, record use doesn't have a return value, so that doesn't help in terms of demonstrating that. But if it had a return value, it would see equals blah with the thing that was emitted. So if you want to then
yeah, what we're looking for inside this function, for example, was that in which case is this actually the line highlighted was actually hit, like the used binding here had its ambiguity field filled by something that we were not exactly sure, and we were trying to look at all the paths that modified that.
Yes, you can skim this. Okay, so it's the used binding ambiguity field that's what you're interested in, right? So in these, I remember, okay, you know what? I remember looking at this last night when I was preparing for this, because I was like, oh, let me see if I can figure out how to answer that question quickly. And the quick answer is that, unfortunately, because of something how it's rendering this, I don't see the ambiguity field for some reason in the output of the printout here, and I don't know why that is. I don't know if it's something about deref or what, but there's some reason why the printout doesn't include it for these use bindings outputs. But having said that, you can clearly see which ones were some, because the cases where it was some are the ones where this line was executed, right? Anywhere that this line was executed is clearly one where use binding ambiguity was non-null. And so you can start from that kind of point of view, saying, all right, I found one where it's non-null. And then you can say, well, I want to know how it got that. How now that I know that I'm in a case where use binding was non-null, then I want to know more about why that is. In particular, what I would like to be able to do is say, okay, let's take ambiguity, let's look in the data flow for it and say, okay, I clicked on ambiguity and now it shows me all the places where it got initialized. And I can click on that and it jumps right to somewhere very low level, somewhere that's in like a pointer right call, right? This is what I was saying before about how you have to also keep in mind your stack trace, your call stack rather. But if I scroll up the call stack, you'll see that we have this thing where it says resolution binding, this ambiguity kind glob versus glob. Like we can jump right to where that data initialization happened that corresponds to the case that you're interested in. for knowing the cases where it's a sum. Does that make sense?
Absolutely, yes, and it's very nice.
That's really helpful.
Okay. Now, like you said, yeah, I've got to have my heart. I'm going to have my heart out in I guess.
Oh, you're overtime.
Yeah, no, my heart out at 11. I have my other meeting at 11:45. So yeah, so let's stop there. And is there any QA? I guess if I'm already over time.
Yeah, I think what would be most helpful for me is just more of these examples of using Pronasco to understand code that you don't understand.
Mm-hmm. Yeah. I've been periodically at times trying to like capture my own development efforts with the screen, trying to do a screencast of development work I've done, and then for various reasons haven't posted one, including like my audio system failing me in the midst of it. But I'm hoping to produce more content like that. In the meantime, I've tried to write down further notes about some ways of using Pronasco and some issues that arise. In particular, one thing that I think is really important to be aware of is in this data flow view stuff, when one is thinking about working backwards from some output to the reason that output happened, one thing that I definitely think is very important to keep in mind is that the data flow view isn't like doing magic. It's just showing you memory updates, which means that there's cases where, the thing you care about, it's a result of some computation. It's not the result of a memory copy. Like it's an indirect initialization is some way to think of it. Maybe like basically the fact that I might have a report ambiguity error here, this error emitted. Okay, this tells me about how this diagnostic builder object, this error thing, if I type error here, I think you can see a printout of what this is. So yeah, this is an example of something else you can do in the notebook that I only found out about last night, where you can actually say, I want to save like that kind of data, that local variable.
That's really nice though.
So yeah, so you can save those things around and then be able to like keep them stashed for later. Once you've like identified that this thing is something you care about, you might scroll backwards and say, well, yeah, but it was constructed from this ambiguity error. Tell me more about where that came from. And so you might have to go and do a little bit of manual digging to like say, this is the thing I care about here, ambiguity error. But once you've done that, going to the point of actually saying, yeah, that's a local variable I care about, like that. I got to get the screen out of the way. Once you've done that, then you can go and use the data flow view again and click on it. And now I've got a view of where this ambiguity error thing came from, and scroll backwards through that in time to where this thing was created, which might occur quite far back in the past, because this thing goes through lots of intermediate copies into iterators, vectors it's collected into, etc. But eventually we work our way back to record use again, which admittedly we demonstrated this earlier about, I think, or was it record use that well, actually, no, I guess Remy mentioned record use. This is an example of how you can find record use potentially of something of interest, rather than having to ask Remy for it. So yeah, it's that kind of process that I recommend people like investigate using. And yeah, the only other thing I'll mention about gotchas with the data flow view is recognize the difference between a box. When you have box data, the data flow view for the pointer is very different from the data flow view for a field of something it points to, right? These are going to be totally different stories about how the pointer was copied from place to place and the fields were left in memory at the same place, versus when the field was copied from place to place. They're totally different computations, and you can learn very different stories from looking at them separately. So yeah, that was the big thing I wanted to sort of get across there. Oh, there is one more tool that I only found out about recently, how useful it is, that I want to make sure I can't let this end without bringing it up. There's a Gdp tool that shows you, if you are familiar with using Gdp, it gives you a live Gdp instance at the point in the control flow that you're sitting at. So if you're not happy about the way Pronasco is like printing out values, if you like using Gdp, you can go into it and say print resolver. Let's see if this works. See, look at that. So it supposedly like this handles like Python GDB extension scripts to get you nice renderings, but when I tried to use it, it didn't seem like it was doing the right thing for Vec. Like I expected a nice printed collection type, and I didn't see it. So I'm going to reach out to the PinoScript devs and find out what we're doing wrong in terms of why we're not seeing our Python extensions enabled. It might be a matter of the way that we invoke GDB has that Rust GDB wrapper script, and we have to do something different to get PinoScript to be aware of it. But anyway, I had to mention this as something else that's cool.
Maybe when you get that answer, you can come back and share it with us.
Yeah. Okay. Well, now I'm definitely over my allotted time for you all. But yeah, are there any other questions?
Let's go ahead and stop the recording.
All right, we'll stop there. Thank you all for listening. All right. Let's see. How do I stop the recording?
You press the record button.
I can't find a record button. That's as if I'm able to. Oh, is it this thing? No, I'm screen. Maybe I'll stop sharing first and then see if that helps me.